Hi everyone, welcome to this talk. As you might have guessed from the title, that is not a technically deep talk, but there are a few stories that I packed to make it useful while I convey this in a kind of a jovial way. Before I get to introduce myself, let me just make it clear a couple of terms, all right? Because now we are global conference and you may not be familiar with these sort of terms all over the place. So what do I mean by oops? So oops is something that a word that we use when we make a mistake. Okay, so if I kind of deleted a file unintentionally, I say, oops, I just did. Yeah, something like that. So whereas ops is a familiar term is for operation. So this is more like a DevOps, that sort of ops. So you get the idea. So the talk is going to focus on mistakes that happened and how we rectify. Then things that are related to production incidents. Okay, so this is Lego.com, and I belong to the team that looks after and runs Lego.com. And I'm a senior engineering manager at the Lego Group, and I work with engineers bringing out serverless features on Lego.com. So we moved to serverless last year, so the backend is running fully on serverless. And so that's the reason why I'm here talking about serverless and sharing few of the experiences we had. Okay, so this is sort of the stats we have. So we have over 200 Lambda functions and 40 or 50 microservices, a bunch of other things as you can imagine running a serverless e-commerce platform. Right. Okay. So let me start with a few oops moments. So before we get going, let me say something about the serverless adoption. So in my understanding, no one starts perfect with serverless. We always make mistakes. We start something very small, and then we kind of even evolve and develop. But the important thing is that every iteration that we go through, we must make sure that we become better. So we rectify the mistakes and we move forward and, better quality and, better application. So that's very important. Okay, let's look at oops number one. So a friendly fire hose went completely wrong. Okay, Firehose is a very simple but very powerful service. It's behind number of click streams and the sort of the event flow, and it can handle millions and millions of events all the time. So there's nothing wrong with the service, but how we use it, that's the thing. So here is a simple click stream event flow. So there are event producers sending events to API gateway. There is the firehose behind it, and then that pushes to S3 bucket, and there's a Lambda function. This is a well-known pattern. It's common. It works beautifully. There's nothing wrong. Two important things when we work with the firehose. One is the buffer size, and the second one is the buffer duration or the interval. Okay, and when this happens, so firehose, if you know firehose, is basically buffers the incoming events in batches and drops the batch of events to the bucket. From there, a Lambda function can be triggered to process the events. The crucial bit is in this sort of setup, the buffer size, the buffer interval, and the Lambda function should be absolutely in sync in order to perform perfectly, right? So if anything messed up, then we are in trouble. So this is, the opposite is to this. What I just said was happened during one, busy period for us. So what went wrong was we had the buffer size initially set as 3 meg and the buffer interval was one minute. That was fine. Now, when we were testing and when we took this to production, it was an off season. Okay, so even within a minute, we were only getting a few K of data, not megabytes. And the Lambda function, even though it was given plenty of resources because it was doing a bunch of things, it was perfectly fine. But when one high season started to happen, we noticed the intermittent failure of this Lambda function. So initially we had no clue. So then people started looking at the logs and they noticed that the failure happens when the Lambda function reaches a certain number of events, and then it was running out of memory and things like that. So the resolution was quick, and it was on the spot fix in order to get things going, was to drop the buffer size to a meg and the buffer interval to 1 meg. Now, the advantage of this one is that now we know exactly what is going to be the buffer size. So that means the Lambda function can be tuned knowing that the maximum it can receive is a 1 meg, okay? So that is what I was saying, that those 3 parameters should be in sync in order for this to, perform well. Right, let's move on. Number 2. SSM parameter store, it's used everywhere. It's something, the dark horse behind your ecosystem, but it can go wrong. It can surprise you if you're not familiar with its limits. Let's see what happens. So bring back the stats. So 200 Lambda functions, more than 200 parameters. So you can imagine the number of interactions between these two. So plenty of reads from number of Lambda functions, and few writes to update sort of tokens or something like that. That's fine. Now, the problem is that when you have this sort of the traffic pattern, everything is smooth. You don't see anything. Everything functions, beautifully. But then you hit this load. So see the 5 times increase. So this is when we started to see certain Lambda functions failing and malfunctioning, and we didn't have much of idea. So digging into that, we found that certain calls to SSM parameter stores were getting throttled. All right. So that's when reality hit. So this was the whoops moment. So default, we had default throughput city. This is so common because when you start implementing serverless, you don't look for all the advanced things. You just get going, right? So, and you don't realize that these sort of, the services like a parameter store and things, they operate in the default setting. You need to move up. Say, for example, if it was a Lambda concurrency, then you probably be more careful to ask for an increase from the default 1,000 to 5,000, 10,000 or whatever. But these things you don't really. So 40 transactions per second or 40, operations per second is the thing. So when we hit the, the peak, we were kind of going above. So the fix was to increase that to an advanced mode. So it's not, easily visible in the documents, but it's there somewhere deep down in the AWS docs. So that's what happened to us. That's what we did. We switched over to the advanced throughput level, and then we got 1,000 operations per second. So it was a simple fix, but it made us to fail before we realized that. Right. Oops. Number 3. When too much became too little, it's so common because we as engineers or developers, often when we provision Lambda functions, we think about concurrency. Sometimes we don't set anything specifically, but in certain cases, for various reasons, we set the reserved concurrency for that particular Lambda function. So this is what happens in this sort of situation. And I must tell you that balancing the concurrency is an art. Okay. And not to mention the provision concurrency now we have, it's always confuses even the expert. What is the reserved concurrency? What is the provision? Where do I hit? Which one to set, So this is again a simple flow that we have. So CloudWatch logs, there is a, the log splitter or a Lambda function that receives the logs. It splits and identifies based on a couple of things. And one stream goes to Elasticsearch and the other stream goes to the monitoring, all fine. So when the engineer originally, implemented, he must have thought that, this Lambda function should have some limit. So, the original concurrency set was 25. And when this went to production again, it wasn't consuming anything, near to 25, probably, 5 or 6 or something like that. Then we hit the high season. Like this, peaks like this. So this is when we started to this Lambda function failed, but we didn't realize that the Lambda function was failing. We saw malfunctioning dashboard metrics and stats and things. So that's where we've noticed there is a bit of, mismatch between the different, the values or the metrics that we are seeing. So the failure was, it failed at the wrong time because it was the high season. I think it was a Black Friday, the high season sale or something like that. And it kind of projected us badly because the business, obviously, you can imagine those sort of situations. Business will be glued to the dashboards and looking for, all the details that goes through. So it was a, wrong moment and wrong time and wrong, the bad experience. So the how did we fix it was to put a better development process in place, like you add the alerting mechanism to know when things get throttled, and also better monitoring to alarm and the people who monitor the different channels and notify proactively that something is going wrong. Okay, so moving on to number 4. This is when you think you given something good for a particular setup, but then it just goes out of proportion somewhere else. Okay, so this is a typical mistake that happens. I mean, don't take it the wrong way, but this is often we do as software engineers. We just copy paste from here and there. It's common practice, but sometimes mistakes do happen. So this is a simple flow. So there is a trigger that invokes a step function, which performs a bunch of heavy lifting things. So this particular lambda function is beefed up with 2 gig RAM, and it runs for 5-6 minutes on average. And the best thing is it's only invoked twice a day. So even though you see that it's running for a long time and given plenty of resources, it's not running frequently. Then a new engineer came along, and a new engineer was to set up a new API with a Lambda function to do a sort of simple query to a DynamoDB. This engineer probably not aware of all the different things, or just a mistake happened. What happened was this engineer copied the code or the configurations of the other Lambda and made it as the configuration setting for this one. The difference is this runs thousands of times, and thousands of times as a minute, and it just runs for 100 or less than 200 milliseconds. And it only required a little above the minimum resource it needs. So that you see the difference. So a simple mistake where it was appropriate for the first scenario, whereas the second one is a bit too much. But a simple mistake can cost a lot of money. I mean, in this particular case, definitely this is not going to bring down your production system, but it may drain your budget if you're not very careful. So if with a high memory, it would have cost $9 or something per month, whereas actually it only should be less than $2. So these are sort of mistakes. I mean, as I mentioned, these are all critical mistakes that it will make a bad impact to customers, or you force you to take the site offline. But these simple things can add to your monthly AWS bill. Right. Finally, number 5, when a key moment turned chaotic. This again is a common mistake, especially when you start your serverless journey and when you start deploying and undeploying all sorts of things. So a simple data pipeline where feeds from our the backend system SAP, it gets dropped into the bucket and triggers a Lambda function. We do a bunch of things, pushes into a queue, another Lambda, and to the platform on the other side. It's a simple flow. Okay, it's a very common data-driven pipeline. It's very powerful, actually. I mean, I showed a simple version. We have over 15 similar pipelines and doing wonderful things with handling different data feeds. The advantage here is that from an architectural point of view, having that the SQS in between, that allows us the buffer to manipulate the different pipelines and tune them accordingly, so that certain pipelines you can tune it too fast to do short polling mechanism, or in certain pipelines they are not critical, you can slow down with the delay or the long polling and things like that. Anyway, so the point here is that there was another internal API that was also feeding things into the bucket. So that is coming from a legacy application. Now, this application, this particular service, at some stage got redeployed. And for some reason, no one knew what happened. It deployed with a new key. And you can imagine what happened, right? The consumers, not knowing that the API key changed, it was failing, okay? And the data feed wasn't coming in at all. And that means we had all over the place the product status and things, and it wasn't a happy, stakeholders situation. So it was a silent breakage. And obviously bad customer experience, because the product status matters when you browse through products, when you try to buy, and in stock product, if you see out of stock, then it's a big problem. And like I mentioned, the business wasn't happy. So how to fix it? Again, better process. So you set up the the necessary alarms and things to make sure that you get notified when there is a 500 or 400x failures from the API. And also, better prompts, like I mentioned earlier, have the channels to, report the failures accordingly. And better monitoring, of course. So this also, blends with the previous alerting mechanism, so that you know exactly what's going on. Right, so those are the 5 simple but useful mistakes that happen. Now let's move on to look something else. So here is a new word, I would say, oopsibilities. I don't think anyone has, coined this word. Anyway, so what I'm trying to say here is, what are the oops possibilities? Okay, so let's look at a few of simple things. We may look common, but they can really surprise you at some point if you're not careful. So okay. And before I go there, and this is just wanted to highlight that when we move to serverless, I mean, I often talk about the mind shift, mindset, and all sorts of things. In simple terms, serverless needs a new way of thinking and working and running application. That's a fact. Everyone knows that. So that means when we work with serverless, we also need to change our way of thinking, especially when we come from the traditional application development or container-based applications. We need to change our way of thinking and our way of working and our way of deploying and running serverless applications. Or just thought of throwing it in so that we remember that it's the importance of the serverless mindset or the mind shift. Right. Let's see. What's the number one oopsibility? High load hiccup. Okay. Now this is very, very common, because so we inspect the traffic pattern, or this chart could be anything. It could be number of sessions, orders, users, whatnot. And this is so common. So we see this peak, and we see that we tune our Lambda functions and the queues and throughputs and this and that, etc. We are happy. Now, one night, without any warning, this happens. So we know that this is the power of serverless. This is the reason why many of us move to serverless, but we are not prepared. Okay, because there are API limits, there are throttling limits, and there are so many other limits we never, thought or taken into account, because we never seen that, because we were fooled by the, the low traffic pattern when we were doing the testing and things. So this is something very important to keep in mind. Number 2. Development to production debacle, and I touched briefly on the API key thing. So there are a number of things that can go wrong, especially the secrets and client IDs. If you are interacting with other APIs and third-party applications and the domain, so when you develop environment, you may have dev dot something something or QA dot something something, but you forgot to change that when you move to production, or you don't have that sort of development process to pick up those mistakes. So that can happen. Resource configurations, again, something you set up in your testing environment, which completely forgot to change in the production. I mean, one thing I always advise is don't mess around with the sort of Lambda configuration or the service configurations between different environments, because that's it's not going to gain anything, because you don't want to spend time giving low resources for a Lambda function in product, in playground than in production. But there are situations where this can happen. Like, for example, if you are talking about DynamoDB global tables, you may argue that, okay, I don't need that setting in a lower environment than in production. So there are variations, but otherwise, please make sure that the configurations are across the same. And finally, this is very important these days, especially with the GDPR, PII, and data privacy. It's a common practice that for the benefit of debugging and analyzing the thing, we enable all the logging and everything in the lower environments. And if in production, be careful, because you don't know where your logs are going to. You may be streaming off to a third-party, monitoring application and all over the place. So this is something very, very important to keep in mind. And number 3 is admin access abuse. This is something I witnessed. That's why I thought of bringing it in here. So this is, one part of our admin, the AWS, the login screen, for example. So on the bottom, you see that the production account has 3 different setups: admin, DevOps, and viewer. Viewer has a very limited thing. DevOps is basically for engineers who are on-call rota, so they may need access to certain things if they are, if they found anything wrong in the production environment. Admin is with full-fledged. So one day I was talking to an engineer, and I was going to talk to him about something in CloudWatch or something like that. And I asked him to log into his the console, and this is what he had. And he only had admin privileges, so he just logged in and more. I was getting panicked because I never log in. If I want to look at something and view something, I never log in with the admin, access. So immediately I stopped the conversation, and I asked the relevant people to give him the viewer access and other things. So this is something important to me. I have seen many admins. They feel the power of having the admin thing. The matter of the fact is, it only requires 1 or 2 wrong keystrokes to bring down your system. It may not happen, but why take a risk? Okay, so that's the one. So a 4th one, ignorance is a blip. So it's no longer a blessing. So know the service quotas. There is a document which list all the different AWS services and the quota limit. Important to know, especially as I talked about the high load issues and all the things. This is something you need to know. Even simple things like the timeouts and thing. How do you keep your API gateway in sync with your Lambda when they too have different timeout settings? So all these different things you need to be aware of. So if you're not aware of these things, please make sure that as you bring each service into production, go through them and get comfortable. And finally, third-party trauma. This is, again, a very common thing, especially when we move to serverless. So here is a typical pattern. This is from, from our production. This is a real graph. And it doesn't matter what this represents, and the 15K, 10K, et cetera, et cetera. So this is a common pattern. So you can see the spikes, right? So the our serverless ecosystem will stand up. Okay, if you done all the the settings and things, it will stand up. But the problem is that million miles away in a different planet, you have a third party you work with, your partner, your SaaS product. So it could be on a different cloud. So while this happens on our side, and that's where the cry comes out, because their system can't cope with this load. So this is another common thing. So please make sure that you use the right patterns. You use circuit breakers and buffering and queuing to make sure that you smoothen that communication between your serverless estate to your third parties and other applications. Okay, so that's all I have today. And let me close with a few best practices and things. So know the service limits, be well architected, because that will bring so much of the awareness and so many things that you may have missed to make sure that you incorporate as part of your architecture and implementation. Serverless lens, if you are doing serverless, please go through the checklist. We have that as part of our service auditing process. Every service we take to production, that should go through this one and get the right ticks and justification if it can't be a particular item can't be ticked. So it's a best practice. And alarm alert act. There are many ways we can do it. We can do via monitoring application. You can do via your Slack channel or Teams channel or emails and SMS and anything. Please make proactively act so that you don't wait until something breaks down, but you will be able to quickly act. And finally, monitor and monitor. This is again very important. So you have your dashboard. Even when you have dashboards, please make sure that they proactively you look for the metrics and set up the necessary alarms and things. So that's all I have today, and let's go build serverless. Thank you so much. Thank you.